velocity time graph for the uniform motion. In this graph, the graph are drawn between velocity and time. This is known as velocity time graph. Velocity time graph give the distance or displacement covered by body. The velocity time graph for the uniform motion will be straight line and parallel to x-axis, and the area of graph will be give the idea of a distance covered by the body in between the time interval t2 to t1. So the area of graph, that is, it was a square, it is a square to multiply AC into CD or BD into CD, and the distance covered, that is area of a graph, and AC is the position of object at velocity axis v, and CD is the time interval, that is t2 minus t1, and for this also. And velocity time graph for a uniform oscillation, and the graph is between the velocity and time is called velocity time graph, and velocity is at y-axis and time is at x-axis. In this video, the graph, it was clear that it is the linear graph for velocity and time, and there are 2 points at the point A and the point B drawing the perpendicular B. Note their velocity initial time and at the velocity at final time, and the slope of a graph is uniform, that is the value of graph is constant because it change in velocity in same in given time interval. So this graph represents the uniform oscillation, and area of graph give displacement covered by the body. Next point, velocity of body is told directly from the graph by putting a drawing perpendicular. By drawing perpendicular from both axes A and B, at x and y axis we get their velocity at different time interval, and the area of graph give displacement of object or a body. We have for point 1 and for point 2, and that means B point. At t1 velocity is v1, at t2 velocity is v2, and area of graph give displacement for that, and area is focus on the, that is a triangle, first triangle, that is OAC, and second is OBC, and area is half of length into height, that is half OC into AC, and for that next triangle half into OD into EC. Putting the values and slope of this curve give acceleration change in velocity upon change in time, putting the value v2 minus v1 and t2 minus t1, and slope of point A and B will be equal, so body will be moved in uniform acceleration because their slope do not change. Comparison of acceleration of the two objects with a velocity time graph, we know that the slope of a graph give acceleration of a body or a object. Then the two body, that is A and B, and their slope is theta 1 and theta 2. Velocity time graph give acceleration value for slope A and for the slope B, and slope change in y-axis upon change in axis, y-axis upon x-axis. That means we have to know that putting the values, dividing the second to the first, we have know that BC is greater than AC, so slope second is greater than slope first, and acceleration slope second give the acceleration value of second, that is acceleration second is greater than first one. Velocity time graph for the non-uniform acceleration, it is curve, we have to see that, and tangent give the direction of acceleration or magnitude. If a body is in the variable acceleration, then graph of velocity time graph is curve as shown in diagram, and the acceleration at any instant can be obtained by finding the slope of a tangent drawing on the curve at the instant, any point. We are moving the last topic, that is equation of motion. Italian scientist Galileo expressed the three relation among the velocity time distance acceleration for a body in a linear motion, and these relation were called equation of motion. Symbol small u, it is initial velocity or speed, v that is final velocity or speed, a acceleration of object, and s is distance and displacement covered by body. First equation of motion, that is v equal to u plus at, second as per equal to ut plus half at square, and third equation of motion equal to v square or equal to u square plus 2as. Proving of equation motion or derivation. Acceleration in change in velocity upon change in time, v minus u t minus 0. Cross multiply and reversing the equation, we have got v equal to u plus at, it is their vector representation. Second equation of motion derivation, average velocity equal to initial velocity plus final velocity divided by 2. We have no the distance travel equal to speed into time, and we have to taking the average speed into time, putting the average speed value, substituting first equation motion v equal to u plus at, and solving this we have got the equation as per our ut plus half at square, and it is their vector representation. Proving for the third equation of motion, we have no v equal to u plus at, then t equal to v final minus initial speed upon acceleration. And for the second equation of motion, putting the time value and taking LHS and solving the equation, we got the value v square u square plus 2as, and is their vector representation. The sign plus minus was taking, it is for retardation or the positive acceleration. Numerical problems we have to discuss. First, brake are applied from a moving bus with a velocity of 30 meter per second. If the brake produce a retardation of 6 meter per second, then find out how much time taken in rest and total displacement cover. In this question, given that initial speed, it is 30 meter per second, final speed is 0, and it is a retardation to be taken minus 6 meter per second, because it is the brake applied and brake produce a retardation, and finding the total displacement cover. V equal to equation first, that is v equal to u plus at. First we have find out that how time interval the body or object is travel, by putting the value is 5 seconds, that is after 5 seconds the bus will be stopped. Using third equation of motion, because final speed is 0, initial are given in question, and we have got the acceleration value in this question, putting the value 330 whole square plus 2 minus 6 because it is retardation, and s is the displacement covered by the body, and solving the equation, that is 75 meter. So the bus travel 75 meter before it come to rest. A car is accelerated with a uniform acceleration of 5 meter per second, and what distance it will be covered in 10 seconds after they start from the rest. Rest means that the initial speed is 0, and time given, that is 10 seconds, acceleration produced, that is 5 meter per second. We are using the second equation of motion, that's s equal to ut plus half at square, putting u is equal to t into 10, and acceleration is 5 by 2 into 10 whole square, solving this, there is 250 meter. That from this acceleration 5 meter per second square, the body cover 250 meter in 10